What if you could ask your AI, what does this user like to eat? And instantly get relevant memories from any previous conversation, even across different threads. We'll set up LangGraph's InMemoryStore with OpenAI's 1536-dimensional embeddings to enable semantic search across execution threads. You'll see how to initialize the store by specifying the embedding model, dimensions, and target fields, including the special wildcard that indexes all content, while organizing memories using namespace tuples like user123, preferences. The pattern uses explicit storeput calls to save memories with namespace keys, and store search with natural language queries to retrieve them, all while maintaining the required emed texts, async signature for embedding operations.
From LangChain, embeddings import init embeddings. Store equals InMemoryStore. Index equals embed init embeddings OpenAI text embedding 3 small hash embedding provider. Dims 1536 hash embedding dimensions. Fields food preference hash fields to embed.
This demonstrates semantic memory storage in LangGraph's persistent system, where the InMemoryStore combines namespace organization with vector search capabilities. The configuration initializes an embedding pipeline using OpenAI's text embedding 3 small model to generate 1536-dimensional vectors, with the fields parameter specifying which data attributes, including the wildcard for all content, should be indexed for semantic queries. Unlike traditional key-value stores, this design requires explicit put operations to store memories and search calls to retrieve them, with all operations organized by namespace tuples like user123, preferences. The implementation follows LangGraph's async-first architecture, where the store's emed texts method handles vector generation while maintaining the original structured data. Memories are stored via store, put namespace, memoryid, memorydict, and retrieved through store, search namespace, query, limit, with the embedding model automatically processing the specified fields during search operations. This differs from deployment configuration handled via JSON by providing runtime initialization that integrates directly with LangGraph's checkpointer system, enabling state persistence across graph executions. This pattern solves the problem of context-aware memory in conversational systems by allowing natural language queries against stored data while maintaining strict namespace isolation. The trade-off involves managing the embedding pipeline and explicit search operations, but the result enables applications to perform semantic lookups like store, search user123, memories, favorite foods, limit equals 3, while preserving the original data structure. The approach is particularly valuable in LangGraph workflows, where maintaining contextual memory across threads is critical, with the async design ensuring compatibility with LangGraph's execution model. Let's break it down line by line.
From LangChain, embeddings import init embeddings.
Imports LangChain's init embeddings to configure OpenAI's text embedding 3 small model, which generates 1536-dimensional vectors for semantic search. The store uses namespace tuples like user123, preferences to organize embedded data, requiring explicit storeput calls to add data and store search with namespace parameters to query it. This is LangGraph's persistent system for semantic search, requiring LangChain > 0, 3, 8, and an async embedding interface emed texts. The Python initialization shown here is for runtime use, while JSON config serves deployment scenarios. Both require explicit search calls like store, search namespace equals memory, facts, query equals, limit equals 3.
Store equals InMemoryStore.
Initializes LangGraph's InMemoryStore as a semantic search store using OpenAI's text embedding 3 small 1536 dimensions for vector embeddings. The field's parameter targets specific document paths, food preference, and all content via, while requiring explicit namespace tuples like User 123, Preferences for data organization. This is the Python runtime initialization requires LangChain greater or equals 0, 3, 8 distinct from JSON deployment config. The embedding function must implement texts for LangGraph's async operations. Actual usage requires explicit calls. Store, put namespace data to insert, then store. Search namespace equals memory. Facts, query equals your query. Limit equals 3 to retrieve.
Index equals.
Initializes a LangGraph InMemoryStore configured for semantic search using OpenAI's text embedding 3 small, model 1536 dimensions through LangChain's init embeddings. The field's parameter targets both the structured food preference field and all document content via the wildcard, while the store requires an async embedding function matching texts. List SDR, list float. Data storage and retrieval require explicit namespace tuples. Use store. Put namespace equals user ID, category, data to index content, then store. Search namespace equals user ID, category, query equals. Limit equals n to query. This is the Python runtime initialization approach. For deployment, use equivalent JSON config with string paths like OpenAI, text embedding 3 small.
Embed. Init embeddings OpenAI, text embedding 3 small, #embedding provider.
Configures the InMemoryStore to use OpenAI's text embedding 3 small model through LangChain's init embeddings. Generating 1536 dimensional vectors via texts for async compatibility. This store implements LangGraph semantic search with namespace organization. You must explicitly call store. Put namespace, key, data to index content, then store. Search namespace equals ns. Key, query equals text. Limit equals n to retrieve matches. The wildcard in fields indexes all content by default, while specific paths like food preference target structured fields. Requires LangChain greater or equal to 0, 3, 8 and explicit search calls. Configuration alone does not enable retrieval.
Dims, 1536, #embedding dimensions.
Configures the embedding vector size to 1536 dimensions, matching OpenAI's text embedding 3 small model output. This is LangGraph's InMemoryStore, LangChain greater or equals 0, 3, 8 for semantic search, where the field's parameter targets specific document paths like food preference. The wildcard indexes all content while named fields target structured data. The store requires explicit operations. Store, put namespace equals user ID, category, data to insert and store. Search namespace equals user ID, category, query equals text. Limit equals 3 to query. Under the hood, it expects an async embedding function with signature texts. List SDR, list float. Aligning with LangGraph's async-first design for persistent, namespace semantic search.
Fields, food preference, #fields to embed.
Specifies which document fields to vectorize in LangGraph's InMemoryStore semantic search system. The food preference field gets dedicated embedding, while serves as a wildcard to embed all remaining content, matching OpenAI's 1536 dimensional text embedding 3 small model. Requires explicit data insertion via store. Put namespace equals user ID, preferences, data, and retrieval through store. Search namespace equals user ID, preferences, query equals. Limit equals n, with all embedding operations handled asynchronously through the texts interface. LangGraph semantic store configuration. The InMemoryStore with init embeddings creates a semantic search store using OpenAI's 1536 dimensional text embedding 3 small model, where the field's parameter for all content or specific paths defines what gets vectorized for similarity search. Deployment uses JSON configuration with embed, dims, and fields parameters, while runtime initialization in Python requires explicit stored output with namespace tuples e.g. User 123, memories, and manual store search calls with the same namespace structure. All custom embedding functions must match the emed text's signature, async, accepting a string list, returning float arrays, and the store integrates with LangGraph's persistence system, requiring LangChain > 0, 3, 8 for string-based embedding formats.
The embedding that dissolves into numbers becomes the only language